Hello everyone, welcome to our channel. In this video we'll fine-tune BERT model for extractive type of question answering, where you provide context and a question to the model, then the model predicts relevant span of text from the context that could be answer. For the second question I'm asking for exact date which is not mentioned in the context. Therefore we should not get any response, but we got an incorrect answer. The dataset that we'll use is Squad 2. There are training examples containing no answers, in case context isn't sufficient to answer the question. If you've watched our token classification video, this may look very similar to that task. In question answering we assign each token to probabilities. First, that this is start of answer, and second, that this is the end of answer. To generate the answer we pick the token with highest probability of being start and end of answer. Instead of BERT base model, we'll use one from Microsoft that is smaller and faster compared to BERT base model. As you can see in configuration, it's a BERT-based model. Passing text pair. The tokenizer combines then with SEP token, and each part has a unique token type ID. We can use it to differentiate context with question. The dataset has answer start index within context string, but we need token index. For that, first we split context in two parts. Doing so we can easily calculate start and end token index. In case there is no answer, we'll return the index of CLS token as both start and end index. The CLS token is also the first token in the model inputs. Let's check if the function works as intended. When there is answer, we need to increment indices by 1, as there is extra CLS token in the input IDs. If the answer exists, it will be in this part. In the Collator function, first we make batch of context question pair. Passing this to tokenizer returns input IDs, attention mask and token type IDs. To calculate the loss, the forward method expects these values instead of labels. GetAnswerPosition function returns token position of answer within the tokenized context. If answer exists, we skip over CLS token. Let's check our Collator function. Input IDs have padding. Token type IDs are 0 for context and 1 for questions. Attention mask is 0 for padding tokens. Everything looks fine. We can now train our model. First, filter out sequences longer than model's max position embedding. Let's train the model for 2 epochs. Let's test if the model has learned something useful. First answer is correct. Since there isn't mention of exact date, so no answer. Let's push the model to Hub. So this is how we can fine-tune BERT-like models for question answering task. If you liked this video, don't forget to subscribe to the channel. Thanks for watching, see you in next one.